it is a multi-threaded HTTP server, so turn it on real quick. Oh, that was quick. Okay. So we get this publisher of Microsoft, which I thought was for Google, but so we get this payload that says, hey, Microsoft wants you to publish this application. Do you trust them? And of course, we trust Microsoft, so we will run this. And so when we run it, everything's looking good. You know, we have Google. Now it's taking a little bit longer for some reason. Like I said, the first time you use this, it's a little bit slow. All right, sacrifice Elliot.
Huh?
Sacrifice Elliot.
Super weak.
Let me refresh this real quick here. Well, hey, I got video backup, so. What's that? So I'll skip through this a little bit. We've already done this. We're going to send an email. And we're going to look at that email. And so we get this published, Java applet from Google. We're going to run it. Oh. That was a back shot. That's not even manly, dude. Seriously. So we run it. Now, one thing to notice, what happened? Anybody notice what happened?
Google.
We're at Google. So when the payload executed, it redirected us back to the legitimate Google site. So the user actually never saw that he was anywhere else other than Google. Now, if I'm like, oh, hey, I'm at Google, cool. I'm going to go in and I'm going to type some stuff and use it. It's all good. So, it browses Google normally, everything's good. However, on our attacker machine, we got an interpreter account, so we fully compromised that machine. So, if it ever worked.
Is there any way to use Google API calls so when it redirects to the Google site, you can actually, like when they put in their login, it will automatically already log them in? You can use like an API key or anything?
Not necessarily. What you can do is when you harvest the actual credentials itself, you can refresh a post from the user account to the original site. That's just a pain. And when I was writing the credential harvester and I started actually programming that, it was a real big pain. So it only worked on certain sites.
If they had chosen the stay logged in feature,
Yeah.
after they submit the password, but the very next thing they see automatically be Google because they already had the.
Yes.
Okay.
Yes. So if they're already logged in, it would obviously do it. Obviously, this is just an example using Google, but you definitely don't want to use it from a Google perspective. You use this when you're trying to go after your organization, right? So that was that. Next is in the website attack vector. You also got the site cloning, and we're going to go ahead and use the Metasploit browser exploit method. That one takes Metasploit exploits, and we didn't really cover them too well. So let's really go really fast into that. So browser-based exploits, if you're not familiar with them, as soon as you go to browse a website, it triggers a vulnerability within your specific browser and then causes what we call generally a heap overflow, a heap-based overflow. A lot of times what we saw with what Elliot was talking about was a stack-based, right? So with a heap, it's a little bit different. Heap is dynamic memory. It's dynamic allocated memory. So what ends up happening is a heap will grow or shrink based off of its requirements, what it needs in order for it to use it. It's just kind of like garbage data, stuff it stores in the heap in order to use it. With browser overflows or exploits, what ends up happening, and this is a pretty cool method, a guy named Skyline came up with it, I think in like 2002 or 2003 or something like that. He worked for Microsoft. I taught him how to play craps and bakes, which is kind of cool. But with heap-based overflows, what ends up happening is, you think about it, there's just a garbage amount of data. The memory addresses are completely random. You have no idea where you're at in the heap. It's going to be different every single time. It's just that kind of space that's used for the application or information that you're entering, right? So what you can do with client-side exploits is it grows the heap. So say, for example, you have 4 gigs of RAM. It'll continuously grow the heap until you hit that 4 gigs of RAM. So if you look at when a browser exploit is actually firing off and you look at your task manager, you'll see your RAM utilization go all the way up to max. What's happening is it's filling your heap with knobs and filling your heap with shellcode. So what ends up happening is you blindly fire into the heap. You don't know where you're going. You're going somewhere in the heap. You fire into the heap, you have about a 92% chance of hitting your knobs, and then down your shellcode and execute your shellcode, and boom, you have access to the system. And you also bypass DEP, ASLR, stack canary protection, all of the preventive measures that are in place generally, right? So heap-based exploits are a much more reliable method from exploiting browsers than any type of stack overflow would be. So what's cool about that though is it generally has anywhere between like an 87% and 92% success rate. Reason being is what happens if you jump halfway into your shellcode or halfway into some other garbage data that's left over from the application, it'll crash. So you'll see Internet Explorer actually crash sometimes. It's just a kind of FYI on heap-based exploits. But Metasploit has a ton of browser exploits based within it. A lot of them are for Internet Explorer. But you go through and you can see a bunch of different types of browser exploits. Now let's search for the Aurora one because that's always the most popular, right? So to use one, you just use the same as every other exploit. Now we're going to set our payload as a bind. We can do reverse if we want to, but. And I generally use 443 or 80 because it's generally allowed outbound. Now, does anybody here do strict egress filtering on their network? I.e., I don't allow very many ports from my clients, my customer base, or my users going outbound to the internet. Right? We've got a few. Do we allow any ports at all for those users to be able to connect up? Yeah. We can. We have to. I mean, it's just. So Microsoft. So Metasploit came out with this thing called all ports, which is a pretty slick method. And what the all port payload does is it actually tries connecting out every single port going outbound. So from 1 to 65,000, whatever. So if you have egress filtering and you allow one port out, it's going to find it and it's going to allow it out.
Does it do it incrementally or does it do it random?
It's random, I believe. I'm not sure offhand. I can't remember. When he blog posted about it, I'm pretty sure he said it was random, but it takes a very long time. So it can take 10 minutes because it fires off 65,000 some amount of ports. So if you're not monitoring, if you're monitoring your egress, and probably notice 65,000 different attempts. But you never know. But it's very good for that. Second off, a lot of people say, well, hey, we filter. HTTP, we inspect, HTTP and HTTPS traffic, making sure that it's legitimate HTTP traffic, right? So Metasploit released a HTTP-based payload. So we have somewhere. I'll just pull from the website. We have HTTP and HTTPS-based payloads. So the actual consoles will fully function over an HTTP-based connection. So if you're inspecting HTTP traffic or inspecting HTTPS traffic, i.e. you do SSL termination, it will let you basically still go by that, which is awesome. So we're just going to do a normal payload. And we don't have an RHOST in this specific example. If you look here, what Metasploit will do is it will create its own HTTP server on port 8080 and with a URI path of something random. So what I generally do is obviously set my server port to 80 because I don't know how I'm going to get somebody to connect me on 8080. Okay. Or you can set URI path and also set the URI path to root. So what's going to happen is it's going to set up a web server. As soon as someone connects to me, it will basically go ahead and execute that. Now, if you're going through and you're doing these types of attacks, I'll show you set does it automatically for you. But I mean, you can always just inject an iframe into a site you compromise or something like that. So if you're going in and you're hacking your company and you compromise a website, you inject an iframe into there. Every single time someone goes, and I only recommend doing this in internal, obviously you don't want customers getting hacked. But every time someone goes to visit that site, an iframe will load, and it automatically points to Metasploit and start exploiting the system for you automatically without them ever knowing about it. So you exploit it, and we're running a specific HTTP server. We'll go ahead and run it. And the person gets this little box here, but there's nothing really exciting going on, right? However, on the other side, we got an interpreter console. Potentially. Yeah, it's just being a little slow. But we were able to center stage, and eventually the interpreter console would come up. Any questions on browser exploits?
I managed to get my browser to do the actual exploit, and it said it connected to it, but I can't get the interpreter to actually do anything.
What do you mean? Like, did you get an interpreter console?
No, it said it connected, but it didn't do anything like the other.
Did it say exploit completed, but not? Or did you actually get the interpreter console?
It said that command shell session 1 open.
So then, okay, so if you get the session 1 opened, what ends up happening is you're running it in the background. So if you do sessions-L, you won't see anything there. You see that session active?
Yeah.
And you do sessions-I and the number of that specific session. That'll interact you with that specific session.
Yep.
Cool. So now you have a interpreter console. Any questions on that?
Is there at least one exploit for each browser?
Yes. Well, I just have generally yes. There's Firefox and Metasploit. I believe there's Safari. There's Opera. So yes, there are exploits pretty much for every single browser out there. Obviously, there's more for Internet Explorer than there is for Firefox or Opera or Safari. But the majority of them, they're pretty much the most latest Firefox one is for 3.5. It was a font tag exploit. So it's going to be, you got to make sure you're out of date with that type of stuff. That's why I don't necessarily go the browser exploit route. I mean, the chances are the person's going to be patched, right? Okay, so that was kind of a walking that one. But chances are that the majority of them are going to be patched. Say Internet Explorer is generally going to be patched. When you get that pop-up saying, "Hey, you should probably patch your system," we're going to patch it, right? So why do that when you can do the Java applet method? The Java applet method isn't a bug as far as Sun is concerned. It's not a flaw. So, someone gets this pop-up that says, "Hey, are you going to trust Google?" Well, of course I'm going to trust Google. So I'm going to run it. And I guarantee you it works. I did a survey at Nauticon, and 4 people raised their hand about using the Java applet. And I said, "What was your success rate?" They said 100%. Mick Douglas from Paul.com said, basically I got told I can't even use it anymore because I'm just rubbing it in. So, you're going to have 100% success rate with it pretty much, unless it's us, right? We're not going to click, run a Java app from Google. So I would. So let's go to the Metasploit browser attack vector within set. Same exact step. We're going to go through the website attack, right? We're going to go ahead and we're going to select the Metasploit browser attack, and we're going to clone Gmail. Surprise, surprise. Now, in this instance, what Set's doing in all these attack vectors is it's grabbing a site, similar to like a wget or something like that, right? And it goes ahead and it automatically rewrites the site for you. So it injects the Java applet into the website itself, or it rewrites the Metasploit exploit into the file itself. So it does it automatically for you. Here it has the list of the built-in exploits.